and hasn't actually placed them. Thanks for that, Michael. So what's place value about? Well, it's used in a number of systems, and it allows us to use the same digits to explain the various places and the various numbers. Having a look at 222, we can see that there are 3 2's, and the 3 2's obviously do not stand for the same number. There are 2 hundredths, 2 tens, and 2 ones, or units in this case. Sorry, I've got too quickly, I'll just go back. If we have a look there, thinking about how can we help students to actually understand all those 2's, it may be that we use some place value blocks or some stars where they can actually cut the different lots out, so that they can actually model the 2 ones, the 2 tens, and the 2 hundredths to get that idea. In our number system, all numbers can be represented by using a finite set of digits. For instance, we only have 10 digits in our system, and every number can be written using those digits. Our place value number system has certain principles. The idea of treating a group of objects as a unit, i.e. in this area here, it means that we can actually exchange 10 of something for 1 of something else, i.e. 10 ones for 1 10. We can use the same symbols repeatedly, as was shown in that example of 222. The position of the digits relative to any digit in the number determines the value of it. To identify the size of the numbers, you need to work out the value of the digits and then add them together, so that you're looking at, I will have an example here, i.e. in 275, the 2 represents 2 hundredths, the 7 represents 7 tens, and the 5 ones. I like the idea, Michael, of using the buttons, etc., and then moving to the next column. In place value, the role of the 0 is really important. First one as a placeholder, it's crucial, and I think it's important for many of our learners to realize that the 0 just doesn't mean nothing, that it actually means there are no 1s or 10s, etc. in that particular column. So when we look at this, when 2 is multiplied by 10, the answer is 20, and we use the 0 to indicate that we don't have any 1s at this stage. Now, students think 0 means nothing. Quite often a good way to overcome that is by using money and suggesting perhaps would you rather have $400 or $40, and showing them that way, or 402 as opposed to handing out $42, seeing that the 0 doesn't help one little bit if you think it means nothing. Some of the materials you may use, as Michael has mentioned, that he uses buttons, beans, that sort of thing. Many of you may have seen place value blocks like the ones shown in the picture here. And we can see that the students need to have a clear picture of the concept of being able to swap 10 of the smaller objects for one of the larger, and vice versa. This is really important when we start to get into subtraction, where they need to rename 1 10 as 10 ones. Often using a calculator is quite a good piece of equipment that you can use, where you can get the students to actually key in, say, the number 7 and just equals, or sorry, number 7 plus 1 and then equals, and just push the equals again and the equals again until you get to 9, and then when you get to 10 they can see that they have no more 1s and they have 1 10. So moving through those little activities is quite a good idea. Here I have a place value chart, and we're going to have a look at just multiplying by 10. Having a look at the cover, firstly having a look at the columns that are involved, where we see there is 1s, 10s, hundreds, and there are 1s. And then we have 1s, 10s, hundreds again, and this time they're of thousands. Then we have 1s, 10s, hundreds again, and we can see that we have, hopefully comes up, millions, yes. This picture is really important for the students to see the repetition of the groups of 3, which will then allow them to actually read large numbers. This particular exercise may not be in the progressions, but it is available and will be available on the web for you to have a look at. I find that a lot of tutors actually run this place value chart off and provide each of the students with a place value chart so that they can actually record numbers. If we have a look here at the 7 is in the 1s column. If we actually multiply that by 10, we actually end up with 70. What we could do is actually ask the students to take their calculators and actually key in 7, and then give them the problem of what do I have to do to move the 7 from the 1s column to the 10s column. Some of them will suggest to you that you just add a 0. So an explanation on that, or some work on that to explain that adding a 0 to a number is basically like multiplying by 10. We want to move that column again to the next spot, and we can multiply it by 10 again, and we get 700. So we've multiplied 7 by 10 the first time to get 70. We've multiplied it by 10 again to get 700. This is the same as multiplying the 7 by 10 times 10, because 10 times 10 is the 100. What happens if we go the other way and we divide by 10? We get back to 70, and then if we divide by 10 again, we get to 7. So from the picture, we're trying to develop that idea that these numbers are actually getting 10 times bigger, or they're getting 10 times smaller. So when we move a number one place to the left, it is getting 10 times bigger. When we divide it by 10, it moves one place to the right and gets 10 times smaller. These ideas become quite important when we want to move into areas like looking at percentages. I wonder what would happen if we divided the number 7 by 10 again. You might like to type your answer in. Thanks, Philippa. Let's have a look. Divide by 10 and we get a 7 in the next column to the right. I'm sorry about my decimal point, it doesn't look very good. What is that column? It's the tenths column. So now we actually have 7 tenths. And this, I think it's important at this stage to not only, I'll just go back to that one, not only look at whole numbers when we're looking at place value, but we should also be looking at the decimal numbers so that the students get a feeling for the whole picture at once, rather than just learn about whole numbers first and then find that there are a whole lot of decimal or smaller numbers second. So when we look at smaller than 1, we can talk about what happens when we divide by 10. We end up with, divide 1 by 10, we end up with 0.1 or 1/10. It's an opportunity to link the fraction and the decimal together. What happens when we divide 1/10 by 10? Using calculators, quite a handy tool for the students to practice with before they actually put pen to paper. We end up with 0.01 or 1/100th. Having the columns supports the students' learning as far as seeing that the number is getting, as it moves to the right, it is getting 10 times smaller. Handy to once again have models such as the place value chart that we saw earlier. We can make up the same sort of thing using small pieces and moving them, exchanging the 1 whole for 10 tenths, and then seeing that one of those tenths has to be once again divided into 10 equal pieces to end up by having hundredths. In the decimals, of course, the decimal point is a very important part of what's going on. What do you think the role of the decimal point is? I'll give you a minute or two to think about that, what the role of the decimal point is. Sandra has suggested that it acts as a separator. To control moving from the whole to a fraction, demarcates the whole and parts and part numbers. Yeah, I like all those. That's good. The official term for the decimal point is it actually indicates where the ones place is located. It's always found just to the right of the ones place, or the ones place is always found just to the left of the decimal point. One that we have always been brought up to, I think, is that it separates the parts of a whole from the whole. One of the important aspects for me is the decimal point never moves. Most of you, I'm sure, will have been taught in the school setting that you move the decimal point. In actual fact, mathematically, this is totally incorrect. It's actually the number that moves. The number moves and gets 10 times greater or gets 10 times smaller. Once again, this becomes quite an important point when you come to be looking at things like percentages. For instance, if you want to find 10% of something, finding 10% is similar to dividing by 10, so you can move the number just one place to the right, and you would automatically have the 10%. Similarly, if you wanted to find 1% of a number, this time because it's 1%, you divide by 10 and divide by 10 again, which is the same as moving the number 2 places to the right. Eventually, I think we all actually move the decimal point, but initially, to give the correct understanding of what is happening, it's really important that we emphasize that the decimal point never moves. Coming back to our place value chart, you can see the decimal point. In here, I'm trying to demonstrate that the decimal point is not the central point. A lot of our students believe that the decimal point is like the fulcrum of a scales and forms the basis on which everything flows. This is actually incorrect. The ones place, or the ones column, acts as the pivot with the rest of the columns matching off on either side. And we can see below there, we can see to the right, to the left of the ones column, you can see the tens. To the left, right of the ones column, we can see the tenths. So it goes tenths, tens, tenths. On the left we have hundredths, and on the right we have hundredths. So we're getting that matching happening. How do you feel about that understanding? Is that a common understanding or a misconception perhaps that your students have? Okay, thanks, Michael. You understand that fully, but you're having difficulty getting it across. I think perhaps the picture. Do you think the picture helps where you actually highlight the ones column as the pivot or the fulcrum, where the others are going on either side? As you say, Kieran, what often happens is when you ask them what is the column to the right of the ones column, they will often say that it is the once column, which of course there's no such thing. And so what we're trying to do is highlight the tens, tenths, hundreds, hundredths. Right, let's have a look at a little activity that I have here. I often use a calculator to start with to find out, do students have an idea of place value? And so I will ask them to key in 465 into their calculators. Then I'll ask them to change the 6 to a 3 without turning the calculator off or clearing it. Have a little think about what your students may do, and think about what knowledge is needed to actually carry this activity out. Yeah, thanks, Karen. What does the student need to know to carry it out? Well, firstly, they need to know that the 3 is actually in the tens, the 6 is in the tens place, and it is not, and so I have to subtract first, and subtract. What do I subtract? I need to subtract 30. Many of our students will initially subtract 3, and of course end up with 462. We can carry on asking sort of similar questions in that vein, where we might be asking our students to change the 4 to a 9, where they have to firstly identify what place the 4 is in, and then decide are they having to add or subtract. It's not a bad activity to use and you can increase the number of digits in the places so that you might have a 5-digit number, etc. And give some good practice at working out what the place and face value of the number is. The last thing that I have here is key in asking them then to move from the whole numbers to the decimal, or numbers requiring decimal understanding, and looking at 700 key in 7.29, changing the 2 to an 8. Once again, what sort of knowledge would they have? Nice question, Sandra, thank you. Sandra was asking whether we would start with the 1s first. I tend to start with the 10s just to get them to think first. If I started with the 1s and said change the 5 to a 1, that doesn't actually get them to really think where is that 5. Whereas once we move to the 6, they have to realize that that is in the tens column, and so the thinking actually starts there. The good thing is if they make that error where they take the 3 from the 5, they're straight away thinking, what's going on here? Why hasn't the 6 changed? So we've actually got a confusion there, and we can actually build on that by going back and looking at it. Thanks for that question. Changing the 2, actually realize that it becomes quite a lot more difficult than the first question, because it actually they need the understanding of the 2 is actually in the tenths column now, and if I'm going to subtract that, I'm actually going to have to put in something like 0.2 or something along that line. Sorry, not add. Yeah, thanks, Michael. Add the 0.6. It is yes, Philippa, it is 0.2. I had a full stop there, key in 7.29, and then a full stop. I should have put in a question mark or something else. It looks like 2 decimal points, doesn't it? It's not good.